Then I would like to say welcome to Alejandro González, who will talk about the evaluation of small wind turbines for rural electrification, climatic conditions in Venezuela. There's a little postponing on it, but we'll catch it up later today. So, Alejandro, please go on. Yes, thank you.
Okay. Well, if you can see the presentation and you can hear me okay, let's go start, right?
Yes, please go ahead.
Okay. Well, the topic I'm talking about is about the evaluation of small wind turbines for rural electrification in communities, most of them really poor communities in rural Venezuela. We are in this study comparing two different communities from different climatic conditions. Maybe you know that Venezuela has a lot of different climate conditions. We have the Andean region and we have the Caribbean northern that is, they have really extreme climatic conditions. So we are going to evaluate the performance of small wind turbines in these two communities. So, well, the problem initially is that maybe you know that when we talk about rural electrification, the small wind turbines are not the preferable option for most of the stakeholders. All over the world, the main technology for rural electrification is photovoltaic, a solar photovoltaic technology, microhydro. These kind of technologies are preferred nowadays, and this is because the small wind turbines are told to be not given the adequate annual energy production. This is because in the most of the project, not the right measurements has been taken. And this is because of the cost and because of the time needed to take the accurate measurements about the real performance that we can expect to have from this kind of technology. So what we want to know is what's the real performance of these small wind turbines after 2 or 3 years working in rural communities in Venezuela from different climatic conditions. So that's a problem. You will have the presentation. I hope I share it with Daniel. So I hope you will have it and you can ask me later or by email whenever you want regarding the problem. So we'll continue. This research is looking for the answer for this question about what's the real problem with small wind turbines as an option for rural electrification in developing countries. So in order to realize the answer, we are going to explain to you the two kind of answers we are looking for achieve. The technical performance is one of them, and the end user acceptance. These two dimensions of the problem are the main issue when we talk about the rural renewable energy technologies as a solution for the electrification and the universal access in poor countries. So these are the two dimensions of the research we made in this time. The technical performance is assessed through computer simulations to analyze the electricity demand and the wind resource. Also, we have the real demand and consumption of all the houses we visit in this case, and we use the simulations to based on real measurements and the real consumption to know the adequacy of the technology for supply all demands in the houses visited in this case. And related to these results, we made surveys to the people in all the communities, is both of them, as you will be told soon. Um, the end users acceptance is evaluated based on surveys, as you will see. So these are the two, I don't know if you can see the pointer, but I hope so. These are the two communities and the location, right? This is northern. Sorry, I couldn't hear you well. If you were asking, I couldn't hear. If if one, I proceed.
I think it was something in the background.
Okay. So this is the community located in the shore of the Caribbean Sea, northern Venezuela. This is the kind of climate, hot and dry. And this is the other located in the Andean mountains of Venezuela. It's a kind of climate, dry and winter, according to Copenhagen climate classification. These are two extreme conditions for comparing the performance of our turbines, which are the same in both cases. I'm going to talk about the technologies in next. So these pictures are shared in order to you to know what's the condition of the population in these places. This is the Andean mountains in Venezuela, in the community in the Sierra in Merida State. In Venezuela, it's the dry winter climate in the Andean mountains. Is 3,500 meters above sea level. And this is in the shore of Caribbean Sea in the Falcon State in northern Venezuela, hot desert climate on the Caribbean Sea. Well, before I proceed with the next slide, I want to say that these places in northern Venezuela, this is like this, La Guajira is here, Paraguaná is here. This has the highest wind potential in South America, according to our research, because we are now working, I'm now in Venezuela, so we are now working in the evaluation of large wind project for our country in La Guajira, which is this place, and in Falcon State, which is near to La Matoya, which is one of the communities visited and we are talking about in this conversation. So Venezuela has a lot of wind potential in the northern coast, higher than other countries in Southern America. It's true that in Argentina, in southern Argentina, they have a lot of wind, but this resource is very far from the big cities, different than Venezuela, where the second largest city in the country is located here. It's Maracaibo, it's next to the higher potential wind. So this research is a kind of also is looking for answers with the performance of wind technology for our country. So which is the technology we're using here? We're using 1.5 kilowatts wind turbine, originally manufactured by a Spanish company called Bornay, but later the technology was transferred to the Venezuelan government in 2012 to the national oil company called Petróleos de Venezuela, which acquired the technology and start to manufacture their own wind turbines for this kind of project like this one. So we use this 1.5 kilowatts turbine for houses, individual houses, domestic appliance, and we use the 3 kilowatts turbines and 6 kilowatts turbines for microgrids or hybrid microgrids. That's a topic we have worked to. So the parts of the project are the rectifier, the tower inverter, and batteries. As you can see, this design is thought for supply 2 kilowatt hours a day, which is the average daily consumption estimated by the national government for the houses in the rural conditions, and is according to the standards a kind of supply that guarantee the sustainable development for the people with this amount of energy. Now, this is the architecture of the project. It maybe is very known for you. This is the small wind turbine. In this case, this is 1.5 kilowatts with 2 blades. The turbines with 3 and 6 kilowatts are 3-bladed. So we have the small wind turbine, the rectifier, battery bank, inverter, and the house. The costs are mainly based on the power converter and battery units, as you can see here, and the total cost is $14,000. This cost is paid by government. This is totally free for the people, and they are not paying any fee by the electricity. Well, so the methodology is based on these two aspects, the technical performance and its user acceptance. We are going to talk directly to this about these topics. And regarding the technical dimension of the evaluation, the first thing we made is take on-site coordinates. I'm going to say that this is after installation evaluation. So it was 2 and 3 years later the installation, so the people can talk about the real performance based on their own experiences. So in this case, we went to the communities, the 2 of them, and take the coordinate for the small wind turbines by our own. And after that, we use the UL-AWS2 Power Wind Navigator to estimate the wind resource based on the coordinates we take, and process this kind of data for obtain the resources. And based on these resources and taking inside surveys for estimation of the load for each house, we compare the energy, available energy, and the electricity demand from the people. Based on that, we take the mean power output, annual energy production, capacity factor, and the levelized cost of energy. We use Homer for the simulations based on the resource calculator. We take account of the real investments and operation and maintenance costs for the systems. This is based on the previous table I showed you. And well, in the in-field work, we made these surveys. We visit all of the communities, and these are the 1.5 small wind turbines in 2 houses. This is La Macoya. This is next to the Caribbean Sea. This is the power converter. This is the rectifier of the small wind turbines, the batteries bank. And we made the work of asking the people what they think about the technology, and you can see the results later. This community is very far from the electricity grid, as you can see, it's 1.5 away, but this is a very unpopulated territory, a very low density of population, so we don't have the capacity to extend the grid to these dispersed houses. This is the results of the daily profile for each of the houses we visit, which were 4. And as you can see later with the paper, this is based on the interviews and the surveys we made. This is the comparison of the daily consumption estimated based on the surveys made, and the wind speed and the annual energy production calculated for each month, or the monthly production of energy. We are comparing the availability of energy and the daily consumption. In this case, for the La Macoya, we have a lot of energy, and most of the people has to burn the excess of the excessive electricity in a resistance, because there are lots of the energy is excessive in this place. We have a lot of wind speed, a very high wind speed, and it's different than what we are going to see in this community in the Andean mountains. This is 3.5 meters above the sea level, and this is the kind of people living there. This is the community. This is the same turbine we use in La Macoya. It's two-bladed 1.5 kilowatts, and we have here 4 houses too. These are the profiles. What you must pay attention at this moment is that the load is lower than in La Macoya. As you can see, the y-axis here, and you compare it with this, it's very different. And this is because in tropical countries or southern countries, most of our developing countries, the electricity demand is based on refrigeration, and refrigeration for the food and climatization for the people is most of the low electricity load, different than in northern countries where the electricity demand is based on climatization, but in other way based on the hot, the calefaction of the people. It's different. So we can see here that most of the load, or the daily consumption is based on the hours of light that the people have. And when it's more light in spring, and there's a lower consumption. And because this hot place needs fans for the people and refrigerators for the food, different than here. They don't use fans for themselves, and refrigerators are not so loaded as in La Macoya. Sorry? Well, I'm about to finish, and you will able to make the questions at the end. So these are the results. The results are that we found that in Andean mountains, we have a lot of problems because most of the people is living on the valleys, and the valleys are not the best place to allocate small wind turbines, and different than in the shores where the people live next to the sea, and this is the best place to allocate the wind turbine. So we found this problem, and we conclude that in mountains where the people is living in valleys, we have a lot of problems with the allocation of small wind turbines. It's better to allocate them in different than directly next to the houses. So we have to centralize the small wind turbines and make a kind of small grid, as we can make using hybrid microgrids in other places, and it's a kind of a different job that we made. But regarding the small wind turbine, we stopped to use them in this kind of Andean communities in Venezuela because of this problem we found here in this research, that is the allocation of the houses is not good for the installation next to them of small wind turbines. Different than in the coastal communities, where it's fabulous, it's marvelous. The energy is excessive, they progress a lot, and they thrive a lot, and they work better with this kind of technology. And in Andean communities, it's definitely better using solar technologies. So what I want to discuss is related to your questions, because this, if you have questions, I am very pleased to answer. Sorry, you can't hear me.
Thank you very much, Alejandro. We are a bit short in time right now because of the postponing of your speak, so we will catch up with the questions later on.